Minecraft physics video responds to a couple of Holiday videos, and I don't think I'll play them, so it'll just piss me off. So anyway, one is on redshift, and he makes the assertion that if my theory was correct, that somehow redshift would make things invisible, and this, that's not how light works. So if I was going half the speed of light, all I can do, even at that speed, is convert light by the 2 factor. So if I had 400 nanometer light, it would become 800 nanometer light if I'm going away. And if I'm going towards you, it would turn to 200 nanometer light. So it would only double the nanometer distance of the light. So it wouldn't make anything invisible, especially considering that there's more radiation on the red side of the scale than there is on the blue side of the scale. So in a sense, the more you redshift something, you'll just convert infrared radiation into visible red radiation. And what you lose on the other end would end up just turning something like white or green light into blue light. So there's no real chance for invisibility until you go blue shift, until you have something coming towards you really fast. That could become invisible because there's not enough blue spectrum, light above the blue spectrum. You have to go all the way to 10 nanometers to get to like X-rays. So there's, once you drop off, once you go to ultraviolet, there's nothing, you're converting it into stuff that is invisible and something that's not even produced in the universe. Whatever you want to call it, a ray of some kind, a V-ray. So there's absolutely no threat of invisibility with any speeds within the realm of possible for matter. But velocity, so it ended up getting into this argument of the expansion of the universe and all that kind of stuff, and that argument creates a sort of a paradox, but it's, I think if you think about it, it's, it's not a paradox. Let's say I have 2 trains going 60 miles an hour, and that's what they're doing. They're working to go 60 miles an hour. They're expending work to travel a certain speed, and they're going a certain distance. So, and I have them going perpendicular to each other. Now, obviously, they've created more than 60 mile an hour worth of distance between them. Now, that extra distance has nothing to do with their velocities. This one can look at that one and say, we have to account for this extra velocity, but they really don't, because that velocity has nothing to do with what either one of them are doing. So it's like the Big Bang argument. If you had a Big Bang and everything's diverging, so say all these things are going the speed of light in this direction, they're not really moving in this direction away from each other. This is the only direction they're moving. They're doing one thing, and one thing only. They're going in a straight line in one direction, and they're not, as a practical matter of their function, it won't be seen. They can't shift to this distance. This distance will have nothing to do with any redshift that's created by the production of whatever's eking out of them. So it has nothing to do with the car analogy of the dropping stuff. And you're dropping it at a rate, and the faster the car goes, the more or less the rate's going to be, depending whether you're dropping in front of the car or behind the car. It can't change that part of the equation. So your real velocity is the velocity your matter has to create. It has nothing to do with an arbitrary statement that, well, look how far you went from this point in space, or this point in space. That's irrelevant to what you're doing. So that would be the first argument, is that you have to recognize that something has a real velocity, and what you're perceiving because of your location, okay, because you're moving in the opposite direction, has nothing to do with redshift. The only thing that matters is whether the emitter or the receiver is moving. That's all. Their movement is what matters. All right. So this sort of gets into the argument of whether something's, if something's moving away from you at a distance horizontally, what you're going to see. And the point would be is that technically you're going to see what light has to be produced, in the sense that the light coming off of this thing would be based on its speed going this way. And so, in a sense, it will be red shifted if it's going away from you, even horizontally, and likewise blue shifted if it's going towards you, in the sense of towards the vector you're heading for. But, this all gets complicated, but I'm just saying there's a distinct difference between the velocity something has and your arbitrary defining of how far away that is from, how fast that is moving away from some point, the point I used to be at. All right, how else to say that? And obviously in the circumstance we're in, we can't see all of our motions, so we can't see the motions that are constructively interfering and the motions that are destructively interfering, in the sense of making more distance or creating less distance. But all of that, I'm just saying, doesn't make any difference to the idea that it requires, no matter what your point in space at any one point is, you're moving, and to change that movement you have to expend energy, and so that one we can understand. How else to say this? Alright, I think that's enough on redshift anyway. I'm just saying that the fact that two trains are making more distance between them doesn't change the redshift coming off of one of the trains. It would still only be the amount of redshift in this direction. The amount has to be compensated towards what it's moving, and it can't have anything to do with the fact that the other object has created more distance between them. It only has to do with what they're going to receive based on their movement from the point of the source. It's probably a better way to say that. Just saying the light is always independent. This is probably the most important way to say it. The light doesn't care how I drop it. I can't drop it forward. I can't drop it sideways. I can't drop it in any direction. It's dropped. And it automatically goes the speed of light in a direction. And that's all it can do. So it can't carry a second direction. It can never be dropped and presumed to have continued to go where I'm going. So that gets to his second video on this stupid relativity crap and this simple experiment I tried to describe of a whole perpendicular in a spaceship. So it's a perfect right angle perpendicular, and you're shooting a beam of light through the hole out of the ship, and you're going 1/2 the speed of c in this direction, and say this is 4 feet, and by the time the light gets here, the hole will be 2 feet ahead here. Okay, it will have traveled 2 feet in space away from this perpendicular, a perpendicular from where it was released. So that my point is the pen is dropped, the light is dropped. Doesn't care how fast this is going. Doesn't care where it's going. Doesn't care whether it's going this way or that way or that way or that. It doesn't matter where it's going. The light is emitted in that perpendicular direction, and it will go in that perpendicular direction. And so my argument is the light travels this way, and in the time it took to get here, the hole went here, and therefore there is no hole here. The hole is as if it was a stationary target. So as soon as the light's dropped, it's moving for a stationary target. It's moving to a destination, a stationary destination. You can't make it do this. You can't make it go sideways and forward. Can't give it two velocities. Can't be done. So there's no way the light is, as an observer standing right here, he can't see, the light go in through the hole. He'll have to see the light hit the spaceship on the side over here, because the spaceship will move and the light won't. The light will go in straight little bursts, doing its business because the ship is moving. So the ship's moving, so this is what they'll see. This is what they'll see. Everybody will see this. the observer here, the observer out here, everywhere, doesn't matter, they'll see this. Doesn't matter how slow this guy's clock is, it can be the slowest clock in the universe. This guy can't possibly see the light go through the hole because it can't go through the hole because the light's a free agent. It went straight, the hole moved, the hole is not the target. It's gone. The target moved away. The light can't go through it. It didn't happen. They say we can make this guy go slow enough to somehow make this light go through this hole, and they can't. No matter how bad his perception is, he can't make the light go through the hole because the hole is here. Okay, the hole is not where the light is going to go, which is towards this straight target. And like I said, if you understand that the emitter keeps moving, okay, the emitter keeps moving, the ship hole keeps moving, so this location from the hole is always going to be the same. So the light will all just hit right here. It can't do any of this crap they say it can do. You can't fix this any other way. Light is independent. Light does not carry a second momentum. Again, their argument is the light, as the spaceship moves, their argument is that this little photon that flies out, going straight, is also going to do the. It's going to drift this way. It's going to go this way also, and then go, and then go this way, and then go this way, and then hit the hole in the future. And so it's going to do that. And it's not going to do that. The light won't travel that path. It won't. It won't keep pace with the emitter. Light isn't like a baseball you throw off a train. If there's a train moving and I throw a baseball off the train, the baseball has this 70 miles an hour this way, and I throw the baseball 90 miles an hour this way off the train. We know that this momentum is kept and that the baseball will do this. So if I want to throw the baseball to somebody I see, I have to throw it behind them so it'll hook into them, because it's going to have this 70 miles an hour going the other way. Light doesn't do this hooky thing. This is not a function of light. And they're just saying it. They're just saying, I know that if I slow this guy down, somehow slowing the light down will somehow make it go this way into the hole. And it won't. This guy's moving, the hole's moving, the emitter's moving, the light is not moving. The light, once emitted, it's free. It's free. It's free. It can't do two momentums. It can't keep traveling with you. The light you see from Saturn is where Saturn was. It's not where Saturn is now, see, from Earth. The light of a galaxy you see in the sky, or star you see in the sky, it's the location where the sun was when it emitted the light. It's not in the location where the sun was moving. Its velocity is not revealed by the light. The light doesn't show you where the sun was going. It doesn't move with it. It's emitted from the point, and it comes to this point, and we're seeing it where it was, not where it actually is today. Fact. And you can say you have convoluted bullshit math to make this happen, but it doesn't happen. This is what's going to be observed by everybody in the universe. This is what you can't change this observation. Now you can make an argument about you shooting light forward with a flashlight. You're going half the speed of light and you shoot the light forward. Well, you can make the argument that this guy's really, really, really asleep, and so he sees the light leave at the regular speed because, his eyes are blinking out. So, time is traveling, so the light can get away from him because his frame rate's slower. So, yeah, relativity works when you use the forward example, because you can just say this guy's asleep most of the time, so he's not seeing the light going the right speed. His frame rate's broken. So then you can make it seem like he actually sees light leaving at the speed of light when it's not leaving at the speed of light because his frame rate's broken. But this perpendicular example breaks all that crap. You can't have it both ways with the perpendicular example. both observers will see the same thing. They'll see the light hit here. That's what the outside observer sees. That's what actually happens. You can't change the fact. It doesn't go through the hole. It hits the ship behind. It hits a place in the ship 2 feet behind the hole. Fact. You can't change it with your bullshit thought experiments. All right, it's probably enough. I don't know if there was anything else necessary to address. He made the argument about the red shift. Making things invisible. I think I took care of that. It's not going to be invisible. There's a difference between your real velocity and arbitrary lines. You can make arbitrary lines anywhere. You know, I can something going this way. I can just make an arbitrary line and say, okay, you're this far this way and this far this way from my arbitrary line. But that doesn't mean anything. This thing did its own thing. It did a thing. The matter had to do this velocity, and this is the only thing it was doing, is its velocity. It just doesn't care about all this other crap. It's changing to move, and that change is something it's doing, period. How else to put this? There's no way, I mean, there's no way to, because it is sort of paradoxical. Like I said, there's a divergence, there's an explosion, two things are moving, they're flying away at 50 miles an hour in an explosion. You can kind of understand that they're not really flying further, faster, just because they're creating distance between this object and this object. Because the two objects have an extra distance that they're moving apart from each other, it doesn't change this distance. It doesn't change that this is the distance they're moving. This doesn't have anything to do with either one of these two things' actual velocity. So 2 bits flying off the explosion, the 2 bits, the fact that they're making distance between them has nothing to do with what they're doing individually, because they're individually just traveling in a dimensional vector line themselves at a speed, at a rate. Yeah, that's probably enough of a way to say it. You can't fix, you can't change the reality that there's just a circumstantial difference. If 2 things go in parallel 50 miles an hour, well, there's no distance difference between them. And if they go in the opposite direction, there's a huge distance difference between them. But it doesn't mean that they went 100 miles an hour. It just means that individually they went 50 miles an hour, and the end result is a whole bunch of extra distance has to be covered. When they want to communicate with each other, they have to communicate a much larger distance. It's just a fact, because they're further apart from each other now. The light won't shift. It'll just take longer to get where it's going. The shift can only be created by the velocity of the thing that's making the light. That's it. I've said it as many ways as I can say it, I think. Alright, enough of a video. But it just, like I said, he uses words like, I'm in error, blah, 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 this, some other thing, and it's like, there's no error here. You can't have it both ways. Something can't do both things. If the observer sees this is what happened. Okay? I mean, you can't make it unhappen. It either goes through the hole or it doesn't go through the hole. There's no way to see it 2 ways. And if it goes through the hole, it's not going perpendicular. Plainly. It's violated the ruler he shows, the square, completely. All right. I mean, yeah, there's no, so he shows a square, a square, as if that's going to somehow prove his point. And it doesn't. It exactly does the opposite, because it obviously is going to violate the square. The only way the light can go through the hole is it has to keep going on, not on the square. It has to keep going crooked, not perpendicular. Anyway, that's the point. can't. It can't go through the hole. There's no way it can go through the hole. Light's a free agent. Free agent. You can't make it do this. It does this, or it does this, or it does this. It doesn't do this. No, it doesn't do that. Homey light don't do that. Can't have two velocities.